Alright, now in this video I'm going to show you the power in, the load power, that's capacitor voltage. This is the load in microamps to the power coils. And this is the amount of current being induced into this 32 gauge with 1 kilo ohm of resistance, powering a little LED light. So roughly 2.8 milliamps of power going to that LED. Capacitor voltage dropping as it's powering that load. The amount of power going to the coils is roughly kind of a tricky one. That random pulse you see where it's going to 180, this magnet triggers the coil incorrectly at the wrong time because I try to get these as close as I can, but this one here is where it gets kind of messed up and pulls more current than normal. But so now if you average in all the other ones, I'd have to say it's about, let's just say 60 microamps. And if we do that, so let's just say 380. And then 0.006. So milliamps. I gotta do this again. What is 60 microamps to milliamps? Kind of got a cold right now. I think I wasn't wrong. Because 1 milliamp should be 1,000 microamps. And if I have 60, that would be 60. So yeah, no, this is right. So it's only consuming that much in watts. 0.002. And then now if we calculate how much current, I don't know the exact voltage though, but I know if you go to here and check the LED, check the LED pulses, not the most accurate, is it? On AC it's telling me about 2.5, 2.7, 2.6. Not working so good on DC. This meter's kind of finicky. I think an LED turns on around 3 volts though. So if we say 3 volts and it has roughly 2.5 let's just go on the minimum of 3 volts. 3 volts. And it's 1.98, 2.25, 2.5. I think I want to say 2.3 milliamps. Kind of roughly go in between. Alright, so now the amount of power output is higher than the amount of power input. Unless I calculated my input incorrectly, but I don't think I did. There should be 1,000 microamps in 1 milliamp. And that would be 2 placeholders, 1, 2, and then 6 I had. So the input to the load is less than what the output is. So does that sound like over unity to me, or you guys? And if, look over my calculations, if I calculated anything wrong. I don't think I'm calculating anything wrong. And I was going kind of high on the, because it really only goes, there's 0.808, 89, but it barely consumes power. And the output is quite high. I don't know, what do you guys think? Is this over unity? Probably isn't, but I don't know. It's kind of interesting. If you take the voltages and calculate it, it sounds like it's over unity to me. But it's hard to measure pulse current. That's another problem. See how this thing never completely accurately measures the input current. But I'm going off of the spikes that it takes. And like I said before, that one initial spike is because one of these magnets are not perfectly in the right position. So it fires like dead on top, straight, like say if you're talking about a gasoline engine, it'd be top dead center. That's when that position is, and then if I were to tweak it a little bit, it messes up the timing, so I have to have it where it is. But roughly, it doesn't really spike anything over 60. That one you saw there was that one that was timed wrong. But either way, there was quite a big difference between the input and output, regardless. You can tell that the capacitor voltage isn't dropping too drastically while powering that load. And it's a capacitor, it's not a battery. I have a 9-volt battery here keeping these supercapacitors about 9 volts, and then I just charge up the capacitor bank with this switch with this high voltage boost converter. So now I'm charging the capacitors up. Takes a little bit of time, but it's not too long. Max voltage is 400. So it'd be a 400 by 500 microfarad capacitor bank. So we're back to max voltage on the capacitor bank. The run capacitors for the motor. These are just the ones I use to charge them. But anyway, what do you guys think? If I calculated it wrong, or if I did it right, then it is over unity, right? It's producing more watts out than power consumption of watts in.